So if you did this a little bit carelessly, you might say that the first number that goes into E is the length of the shortest hop path from A to E, which in this case would be, well, there's two ways to get with distance 11 to here in 2 hops, and then another 7. So you might have said 18, but in fact, it won't expand D into E until it knows the shortest distance to D. And the shortest distance is going to be 10, because we can go this way. 4 plus 1 is 5, and 5 is 10, so it should be 17. But let's actually simulate it and see what happens. So we expand out A into C and B, and once we've done that, the shortest non-completed distance is the one to C, so we're going to lock that down, and then we expand from that node C. There's 2 edges to incomplete nodes, C to D and C to B. The C to B has a length of 1 plus the length of 4 we already had, so that actually improves this one to 5. And a new node joins the picture, D, and C to D is 7 on top of the 4 we already had, for a total of 11. All right, of the non-completed nodes, B and D, the one with the smallest distance is B with a distance of 5. So we can lock that down and look at the outgoing edges from B, which is just this one that goes to D, which has a length of 5 plus the 5 we already had for a length of 11 in B, which D, which improves D, 10. And it is the only node that we can reach at this point that we haven't completed yet, so we can lock it down, expand out its neighbors, which are F and E. F gets 20, and E gets a 17. And not only is that the first number written in E, but it is the final one, because the very next thing we lock down is E's distance. We don't lock down F's distance until we actually discover that there's a shorter path, a 19 length path. All right, so I think you understand this well enough that we can try to code it up.